Okay, technically this video has nothing new. We've talked about how to find force of gravity, we've talked about how to find force of friction, we've talked about the difference between Newton's first law and second law. This video is purely examples, walking you through how to do problems that you'll have to do in class, and you'll eventually have to do on quizzes and tests. So, especially if you've been struggling with free body diagrams, pay very close attention to the processes that I take you through throughout this video. So, we did a warm-up like this for second law. Many of the instructions, or the steps you take for a second law force diagram, are very similar to first law. Just one major difference is that typically you need to start by drawing your net force diagram. Alright? Because you'll be given, say, the acceleration of the box and the mass of the box, and therefore you need to figure out, okay, what is my actual net force? And then from there, you can use the net force instead of 0 to figure out the missing pieces. Alright? So once you know your net force, the process starts to become very similar to first law. Find F sub g. Take your mass, multiply it by gravity. If you're given mu and now you know normal force, you can find your force of friction. Alright? Say another big difference between first law and second law diagrams is this last step. Rather than making sure everything cancels out and makes a net force of 0, you need to make sure that your net forces add up to whatever your net force diagram looks like. Alright? If it's 5 newtons to the right, then there better be 5 more newtons on the right than there are on the left. Okay? Things like that. So let's work through some problems. So first example is draw force diagrams for 6 kilogram box accelerating at 12 meters per second to the right. Assume no friction. Alright, so I'm going to start by letting myself know that the mass of both of these is 6 kilograms. Alright, we know that the box is accelerating to the right, so I'm going to draw my F net box first. We know F net is to the right. And we also can find F net. F net is equal to mass times acceleration. So we can plug in 6 kilograms times 12 meters per second squared, and you end up getting 72 newtons. So this is 72 newtons. Alright. Another thing to remember is somewhere you should be drawing your acceleration vector and just labeling that. It does not go on a box, but it does go in the diagram somewhere. So we know our net force needs to be 72 newtons to the right. Alright, so let's move on to our other diagram. So first diagram is net force diagram. Second diagram is the force diagrams we've been dealing with before, where you put all the forces that you have on the diagram. So we know we'll have an applied force. We know we'll have a force of gravity, right? And then since it's accelerating only to the right, we know it's not falling, so it has to be on a surface. And in this class, we're always just going to work with things that are on surfaces, so we know we'll have a normal force. Instead, assume no friction, so we don't need to figure out a frictional force. So to find normal force and force of gravity, you do the Fg equals mass times gravity, or 6 times 10, and you get 60 newtons. Okay? We also know that based on our net force diagram, top and bottom should cancel out to 0 because there's only a net force going to the right. Alright? Now, since our net force is horizontal, that 72 newtons needs to go into the forces in the horizontal direction. Since there's only one, that also tells us that our applied force is 72 newtons. Okay? So, you need to be systematic with this. You need to think carefully and just remember the things that we've done before and just make the slight adjustment for the fact that instead of everything adding up to 0, your net force has to match your net force diagram. Okay? So this time we have friction. So draw force diagrams for a 6 kilogram box accelerating at 12 meters per second to the right. Assume friction is 13 newtons. So we're going to, for sake of ease here, we're going to stick to everything kind of being the same mass, same acceleration, and just make slight changes so you can see how that affects things. So we know our acceleration is 12 meters per second squared. We know since it's accelerating, the net force is going to go to the right. Nope, I'm making a cardinal mistake in drawing an acceleration on my force diagram. The only thing that goes on a force diagram are forces. So this should be F net. And just like before, F net is equal to mass times acceleration, which is going to be 6 times 12, or once again, 72 newtons. Okay? So net force diagram doesn't look any different in this situation. The force diagram, on the other hand, will. So we know our mass is 6 kilograms. This time we're going to have all 4 forces on the diagram. Applied force, normal force, force of gravity, and a force of friction that we're given is 13 newtons. Alright? We can find force of gravity the same way we did before with m times g, or 6 times 10. So that's 60 newtons, and this is 60 newtons. Now, the thing here is that F of F and F of A have to combine to be 72 newtons. Okay? So essentially you have FA minus F of F, since F of F points to the left, that makes it negative, has to equal 72 newtons. Alright, or F of A minus 13 has to equal 72, since we know force of friction is 13. So FA is equal to 72 plus 13, or 85 newtons. Okay? That's the big, huge difference here that makes these diagrams different, is that instead of everything canceling out, it has to equal whatever your net force diagram shows. Okay? So, sample 3, same idea, except now instead of straight giving me friction, I have to figure out the friction using mu. So, start out the same way. 6 kilograms. We know we're accelerating, so the F net goes to the right. Once again, to find F net, we use mass times acceleration, and let me draw my acceleration vector in here. So this is going to be 6 times 12, or 72 newtons. Looks the exact same. Okay? So let's try figuring out our force diagram. So once again, we're going to have all the forces on here. Fg, Fa, Fn, Ff. So this time we aren't given one explicitly, but once again, use F of g equals m times g to find gravity and normal force. So 6 times 10, this is 60. This is 60. And then to find force of friction, we use mu times Fn, or force of friction is going to be equal to 0.74 times 60 newtons, which ends up being 44.4 newtons. Okay? So now our last step is figuring out F of A, which we have to do the exact same way before. FA minus FF has to equal 72 newtons. So it's FA minus 44.4 is equal to 72 newtons, or FA equals 72 plus 44.4, and that ends up giving you 116.4 newtons of applied force. Okay? So if you think about what we did, first we found our F net. Second, we found F sub g. Third, found force of friction. And then fourth, use that to find FA. Okay? So, we did talk about this yesterday. We need to make sure we cover deceleration. So draw force diagrams for a 6 kilogram box decelerating at 12 meters per second squared, but moving to the right. All that does is change the side that our net force arrow goes on. Deceleration means it's going to be pointing to the left, so our F net is on this side. Otherwise, the process is exactly the same. So M equals 6 kilograms, F net equals 6 times 12, or mass times acceleration, which gives you 72 newtons. The only difference with deceleration is that the newtons go to the left, and technically they're negative. Okay? So, for the force diagram, we have to draw on our forces that exist, and this says assume that there's no applied force. So essentially what happened is you've got something that's coasting, and it's slowly coming to a stop. So this something has a force of gravity, it has a normal force, and it has a force of friction. Okay, so M is equal to 6 kilograms. You can use F of G equals M times G to find normal force and force of gravity. So that'd be 6 times 10, 60 newtons. 60 newtons. And then force of friction, if you notice, since we have no applied force and our vertical forces cancel out, force of friction is equal to your net force. So that's 72 newtons. Alright? So last one is a challenge. And this one kind of takes everything we did in the last acceleration problem and applies it to, doesn't even apply it to, but this time we are using deceleration and F net to find force of friction and mu. Alright? So, this process starts the same. Let's figure out our net force diagram. Since we're decelerating, F net's to the left. Mass is 6 kilograms. F net equals mass times acceleration, or 6 times 12, which is 72 newtons. Okay. And then let's start drawing what's going to be on this diagram. Force, gravity, we have an applied force, we have a normal force, and we have force of friction. Alright, and mass is 6 kilograms. We know from the problem, FA is 4. We can find F sub G by doing mass times gravity. So these are 60 newtons. Okay, and for this one, to find force of friction, we need to use our net force. So, same thing, FA is going to be equal, let me rephrase that, FA minus F of F is going to be equal to, since the arrow is pointing to the left, negative 72 newtons. Alright, so we're going to have 4 newtons minus F of F is equal to negative 72 newtons, which then if we move the 4 newtons over, since it's positive, you'd have to subtract them. We'll have negative force of friction is equal to negative 76 newtons. Those negatives can cancel each other out so that we know force of friction is 76 newtons. Okay? So we found force of friction, and we have normal force, so we can use our F of F is equal to mu times Fn to solve for mu. To do that, you divide both sides by Fn. That cancels the Fn out on this side. Mu is equal to your force of friction divided by your normal force, which is going to be 76 divided by 60, which ends up being 1.27. Okay? So this is, I'd say, probably as hard as the problems will get, but all of these are relatively difficult if you have absolutely no organization to how you process this. Alright? If you notice, for the most part, there is a pattern of the order that you do things. Alright? The equations will be on quizzes and tests and things like that, so just when you get stuck, look at the information you have. Which of those equations could you use to find another force? And then with that other force, is that going to give you enough information to keep going? Okay? So, there is no online assignment for this one. Just make sure that you have some really good detailed notes tomorrow. Even better if you can come up with your own list of, what's the order to do this stuff in. But I will see you in class.